Hello Math 3 students. If you are in class today, then you are in the right place. You found your video on our first lesson. Remember that we talked about how my classroom works and the fact that this is going to be your lesson with your notes. And as you watch this video, you will fill in the notes and you will write what I write. This is really a review. You're not learning anything new today, but this is a review from Math 1 and Math 2. But tomorrow when you come to class, we won't be doing a new lesson. You will be doing problems based on what's in this video. So I'm not sure how much of the notes I'll be able to get through in this video because this is a new set of notes for me. So what I'm probably going to do is just go as far as I can in about 30 minutes. And I do move kind of quickly, but of course you can pause the video where you need to. You can rewind it, but remember on Edpuzzle, if you do rewind the video, you will have to watch from there. You can't fast forward the video. And there's a good reason for that, of course, so that I know that you watched the whole thing. Also remember that there will be problems embedded into this video, so I'll ask you questions every once in a while and you'll have to answer those questions. They will be graded. The answers will be graded based on accuracy. So be careful as you answer the questions. And most videos only have 4 or 5 questions embedded in them, but just to kind of keep you paying attention. That's really why I put those in there. So let's get started. Okay, so again, this is a review of linear functions and quadratic functions, which you had in Math 1 and Math 2. So hopefully there won't be anything very new to you here. Let's start at the top of page 1 in your notes. You should see this at the top of page 1. So we're going to talk about linear functions first. Linear functions, of course, are functions that create a straight line. So I've pulled up Desmos over here. So this first function right here, y equals 2x plus 3, that would just create a straight line, as you can see here. And this is in what we call slope-intercept form. So I want to write that at the top here. So let's write slope-intercept. That slope-intercept form is y equals mx plus b, where your m is the slope, m equals the slope, and the b is the y-intercept. And so if we go back over here and look, the slope here is 2. So we could count like from this point to this point up here, we would be going up 2 and then to the right 1. We'll talk about that more later. Also, the y-intercept is 3. In other words, that is where the graph touches the y-axis. So it touches the y-axis at y equals 3. Okay. So, and then this blank right here, we're going to write the word slope in here. Slope is the rate of change of the dependent variable y for every increase by 1 of the independent variable x. That's just a fancy way of saying that y depends on x. X has to do something so that y knows what to do next. So if we chose for that one that we were looking at over there, y equals 2x plus 3, well, if x equals 1, then 2 times 1 is 2 plus 3 is 5. So that gives us the y. So the y is dependent on the x. The x, we could just put a random number in there. We could put a 0 in there. So if x is 0, then y would be 3. If x is 1, y would be 5. So that's all that means right there, is that every time we choose a value for x, we can plug that into x and figure out what y equals. Okay, so how to calculate slope? If you're given 2 points, and let's write this down here, given 2 points, like 2 ordered pairs. If you're given 2 points, then m equals, or the slope equals, y2 minus y1 over x2 minus x1. Now let's do an example of that real quick. So let's put an example right here. You might have to write really small. Let's say we had a problem that says a line contains these points. Let's do ordered pair 0, 2 and ordered pair 4, 8. Okay, so this is my x value, this is my x value, this is a y, and this is a y. So we could call this 0 would be our x sub 1, okay? And the 2 would be our y sub 1. The 4 would be x sub 2, and the 8 would be y sub 2. So then what we would do is we would take these 2 points, we plug them into this little formula right here. So we have y sub 2, which is 8, minus y sub 1, which is 2, over x sub 1, 4, minus, sorry, x sub 2, 4, sorry, minus x sub 1, which is 0. So that would give us 6 over 4, which we would simplify to 3 halves. So the slope, in this case, would be 3 halves, because we just divide each of these by 2 and get 3 halves. Okay, so that's an example of slope and how you would calculate slope if you're given 2 points. Okay, the y-intercept, you can abbreviate that. The y-intercept is the y value of a function when the independent variable is 0. In other words, when x is 0, the y-intercept is the y value. So in this particular line, the y-intercept would be 2. So if you're given like a point where you've got a 0 for x, then that other value is the y-intercept. Let's say you are given an equation. So let's say given an equation, and let's use y equals 2x, let's do plus 6 this time. Y equals 2x plus 6, and you're told find the y-intercept. The y-intercept would be the value when x equals 0. So I would plug in a 0 right here for x, and then just do the math. 2 times 0, 0 plus 6, y equals 6. So that means the y-intercept equals 6. So this would be my answer to that example. Okay, so down below that little section, it says identify and explain which tables of equations are linear functions and which are not. Now, we have a poster in our classroom that talks about which, if a relation is a function. That's not what this is. We're looking for a degree of 1 on an equation. And what I mean by that is I mean that the highest exponent on the variable x is 1. So in this case, because there's no variable listed here, we assume that the variable is 1. So we would say, yeah, this one's linear. And the reason we know it's linear is the degree, or the highest exponent, is 1. Okay, now look at B, 1b, and we see that the exponent on the x here is a 2. So this is not linear because the degree is 2. This is a quadratic. This would make a parabola. And if I'm going to look over here at Desmos again and get rid of that one. This one, see the exponent is 2. And so this makes a parabola, a U shape. All right, moving on. Let's look at part C. Okay, so what we want to do here is we're looking to see if this is linear. And I'm looking, and what I do is I just go from point to point and see if the change is constant. So this one from 0 to 1, that's 0 plus 1 is 1. 1 to 2, that's plus 1. 2 to 3, plus 1. So far I'm good. And then I go from 3 to 5, and I have plus 2 here. Same thing here. Down here, this is plus 3, plus 3. These are all plus 3. So since the change is not consistent between the x and the y, this is not linear. So just write not linear. This one over here though, I have, let's see, this is plus 1, plus 2, plus 3, plus 4, plus 5. Also what I see down here on the bottom is plus 2, plus 4, and these all double. Another thing that I could do is check the slope. So if I chose like 0, 3, and 1, 5. I could check the slope. 5 minus 3 over 1 minus 0. That is 2 over 1, or 2. And then I can go up here and do another set of ordered pairs. Let's do 6, 15 and 3, 9. Those are going to be negative numbers. 9 minus 15 over 3 minus 6. And that's going to be negative 6 over negative 3. That's also 2. So the slope is consistent among the points. So this one is linear. All right, let's move on. Okay, identify the slope and y-intercept, then graph. These should be really easy. You've done this so many times in Math 1 and Math 2, I'm sure. Y-intercept is always this b number. So the last number is the y-intercept. In other words, on the y-axis, the 3 is going to be a point. That's where it crosses the y-axis. Now, I have a negative slope. A negative slope is going to go this way. So if that line doesn't go that way, I did something wrong. So let's see, a negative 2 slope, there's a couple different ways I could go from this y-intercept. I'm either going to go up or I'm going to go down from there. If I go down 2, let's do up 2. If I go up 2, that is a positive direction. But if I go left 3, I'm sorry, left 1, sorry about that, that's the y-intercept, left 1, then that would make that a positive over a negative, which is still a negative slope. So as long as I go either up and left, so up 2, left 1, if I go down 2, that's my negative direction, and then right 1, that is a negative over a positive, and that's still a negative number. So as long as you still get a negative number, it's fine. So I could either go up 2, left 1, or I could go down 2, right 1, and see I've still got that same slope. Let me get my line tool. So there's my line. So it should look something like that. All right, and then the next one is a set of ordered pairs. Now, remember I told you that if you have an ordered pair where x equals 0, then that other number is the y-intercept. So my y-intercept, I already know that's negative 4. So I can go ahead and mark that 1, 2, 3, 4 right here. So mark negative 4 there. And then I just need to find the slope. So I can take any 2 ordered pairs. I'm going to take ones that have whole numbers instead of fractions, because it's just going to be easier to work with whole numbers. So I have one ordered pair that's 4, 2. And then I have this other ordered pair down here that's 0, negative 4. So this is x1, y1, x2, y2. And so I'm going to take y2 minus y1, negative 4 minus 2, over 0 minus 4. And that's going to be negative 6 over negative 4, which is, let me make sure, 3/2. So it's a positive slope. That means it needs to go this way. So I'm going to go up 3 and to the right 2. So let's see, up 3 to the right 2. And then I can do the same thing again. 1, 2, 3, 1, 2. And then there's my line. Put your arrows at the end of it. Okay, so our next section, section 3, part A. And let me just mention this while I'm thinking about it. Sometimes I will fill in all of your notes, and then sometimes I will leave some of them blank. So if there are sections that I don't fill in, like I might do A and not B or something, then tomorrow we will be doing that during class. So you'll be filling in the rest of your notes and doing your classwork assignment. So just understand, if there's a section that I don't do, if I don't tell you cross this part out for some reason, you are responsible for making sure that you have that done. Okay, so this one says write a linear function in slope-intercept form. So we need to end up with an equation that looks like this. So I need my slope and I need my y-intercept. Easiest thing to do here is find slope first. This is x sub 1. This is y sub 1. X sub 2, y sub 2. So 5 minus, understand, it's minus this number. So minus negative 13 over 4 minus negative 2. Okay, 5 minus negative 13 is the same as plus positive 13, so that's 18. This is the same as 4 plus positive 2, that's 6. So my slope is going to be 3. So I'm going to put a 3 for M. Now what I need to do is I need to find B. I need to find the y-intercept. Well, I have an x value and a y value here. So what I could do is plug in the x right here and the y right here. And then my B is the only thing that's unknown. So if I do that, I would plug in a 5 for the y. The 3, or the M I know, 3 times. And then the x, I'm going to plug in the 4 plus B. So now the B is the unknown. So I just do the math over here and solve for B. So 5 equals 12 plus B. Subtract 12 from both sides. And I get B equals negative 7. So then I can plug in the negative 7 for the B. And I have y equals 3x minus 7. So this is my answer here for slope-intercept form. All right, next one is a set of, it's a table, so it's a set of ordered pairs. These are my x's and these are my y's. So let's find slope first. So I see right here, this is my y-intercept because I've got x equals 0. So if I have y equals mx plus b, my y-intercept is going to be negative 5 or minus 5. So I need to find the slope next. Let's go with these first two ordered pairs. So I have negative 2, negative 4, and 0, negative 5. All right, so negative 5 minus negative 4 over 0 minus negative 2. That's plus positive, so that's negative 1. And that's plus positive over 2. So my slope is negative 1/2. So I'm going to fill in a negative 1/2 here. That's all I need to do. Y equals negative 1/2 x minus 5. Okay. And then let's see, the last one, I'm given the graph. And so here I just need to look and see where my y-intercept is. My y-intercept, so B equals 5. And then to figure the slope here, what I can do is go from one point to another, and they've given us the points here. I could use the slope formula, but if I just count from this point to this point and only use like these blocks, I go down and then over, I can figure out what the slope is. So I'm going down 2 and then to the right 3. All right, so down 2 to the right 3. Well, down is a negative direction and right is a positive direction. So my slope, my M, is negative 2/3. So my slope-intercept form would be y equals negative 2/3 x plus 5. Okay, so the last thing we're going to do, well, next to the last thing we're going to do is this word problem. And then we're going to go back to number 3 and we're going to talk about standard form as opposed to slope-intercept form. So let's look at this word problem first, and then we're going to go back to page 1 for a second. And then we'll be done with this video. All right, so look at the word problem. Dracula is making bracelets for a charity fundraiser. He already had 22 that his friend Frankenstein made. Okay, so anytime you see a word problem that you know is a linear word problem and you see that something has already been done before we start the line, this is always your y-intercept. So this we already know is going to be our y-intercept. Okay, so that's going to be that plus B part. He adds on 6 bracelets every 15 minutes. Okay, so then the 6 bracelets would be, this would be the y, because depending on how many minutes he's been working, that's going to determine how many bracelets he's made. So the minutes is the x, because that is what we call the independent variable, which you don't need to remember that part, but we need to understand that depending on how many minutes he works, that will tell us how many bracelets he has. Okay, so this is the y and this is the x. So write what is a linear function or a linear equation that could model the situation. Let t represent time and b of t, so this is our y. Anytime you see an f of x or a g of x or a b of t or anything like that, that's the same thing as y. that represents the number of bracelets made. So I could write this as B of T, which is what they've asked us to do, which I could also call Y, like I said. B of T equals, and then mx plus b, we need to figure out what the slope is. The slope is the difference in y over the difference in x, or in this case, just 6 over 15, which when we simplify that, excuse me, we get divide by 3, sorry, 2/5. So the slope is 2/5. So my equation would be B of T equals 2/5 x plus, and then my y-intercept over here, plus 22, because that's what he already had made. So this is my my equation for this function. Now this is evaluate B of 35. All right, so evaluating a function, all that means is you fill in, you know what, I should put T right here. Let's erase that, the X, and let's put a T right there, just so we don't get confused with what goes where. That's still the X, but we're going to put a T, and I usually use a capital. I mean, it's a cursive T, sorry. So B of T equals 2/5 T plus 22. So if I'm asked to evaluate B of 35, you see how they filled in a 35 instead of the T, which means I fill in a 35 right here for the T. So that is going to be 2/5 times 35 plus 22. All right, let's talk about 2/5 times 35. If I multiply, I'm going to go over here, 2/5, if I multiply that times 35 over 1, my 5 and my 35 can be simplified. So if I divide both of those by 5, I get a 1 there and a 7 there. So then I just multiply what's left over. 2 times 7 is 14, and 1 times 1 is 1. So that equals 14. So this part of the math here, this part of this side, equals 14. And then I bring down my 22. So B of 35, in other words, 35 minutes, how many bracelets can he make? Well, he already had 22, and then he can make 14 more. So that is 36 bracelets. So in 35 minutes, and it asks me to write a sentence. So let's write a sentence. In 35 minutes, Dracula made, or would make, say will make, 36 bracelets. So there's my sentence. All right, if Dracula has a goal of having 100 bracelets made in total, how long will that take him in minutes? So what we do here is we fill in 100 for the B of T. So 100 bracelets is what he wants to make. So how long would it take him? That means that the T is what I don't know. So 2/5 T plus 22. So then I just solve for T because that's my time. Okay, so let's subtract 22 over here. I'm going to move over here. That's 78 equals 2/5 T. And then I need to get rid of the 2/5. To get rid of 2/5, I need to multiply. Let's multiply times 5 first. So if I multiply times 5 over 1 here, and I multiply times 5 over here, I get 390. 390 equals, these 5's cancel, so I'm left with 2T. And then I can divide by 2. I could have multiplied times 5 over 2. I think it's a little bit more confusing. It's a little bit easier to do it this way. So T equals 390 divided by 2 is 195. So it would take him 195 minutes to make 100 bracelets. All right, so the last thing I want to do is go back to page 1. Let's look at that last section 3. And so it asks us to write SlopeIntercept Form. This is SlopeIntercept Form. On your classwork tomorrow, though, you're going to be doing standard form also. So this is SlopeIntercept. And I want to talk to you about how to change these to standard form. So a linear equation or function in standard form. This was y equals mx plus b. Standard form is ax plus by equals c. So here's what you want to do. If you've got y equals 3x minus 7, you want your x's and your y's on the same side. So for this one, all I'm doing is moving this 3x. Let's rewrite this. Y equals 3x minus 7. The tricky thing is when you get fractions, and I'll show you one of those in a minute, I need to just subtract 3x from both sides. So then I have negative 3x plus y equals negative 7, and that's it. It just has the x's and the y's on the same side. If I had like a 2 here, a 4 here, and an 8 here, then I would divide through by 2, but I don't have that situation. Let me show you. I'll show you what that might look like. If I had 2x, and you don't have to write this part, plus 4y equals 8. So if I end up with this, what I want to do is look and see, does each of these have a factor in common? I can divide all of these by 2. So that's what I would do. I would divide every one of these terms by 2. So 2x divided by 2 would be x, 4y divided by 2, and then 8 divided by 2. So that would actually be my answer if I had something like that. I didn't have that here, so I didn't have to do that. But just in case you see something like that, you would need to do that. Okay, so on this one, standard form, let's move the negative 1/2 x. Let's add 1/2 x on both sides. I end up with 1/2 x plus y equals negative 5. All right, so here's the tricky part too. Most of the time, they're not going to want you to have fractions in your answer. So I would need to multiply through times something so that I could just have an x right here. Well, I multiply by the reciprocal of whatever that fraction is. So the reciprocal of this is 2/1. So I have to multiply both sides. And I don't have to put a 2/1 there, but I will. Multiply both sides through by 2/1. So if I multiply 1/2 times 2, I get 1. So that's just x. 2 times y is 2y. And then negative 5 times 2 is negative 10. Okay, so see, I have a 2 and a 10 that I could divide both of them by 2. But I don't want to do that because if I did that, I would end up with that fraction again. So this is my standard form here. All right, and then the last one I want to look at is number 3c. Again, I have a fraction here, so I'm going to end up having to multiply times something, but let's take one step at a time. Okay, so on this one, I'm going to add 2/3 x to both sides. So that's 2/3 x plus y equals 5. Got rid of it there, so that gives me 5 on the right. Now, I don't need to multiply times 3/2. What I do need to multiply by is this denominator over 1. Okay, so if I multiply this times 3, and I got to multiply this side times 3, sorry, times 3 also. If I multiply this times 3, these 3's cancel, and I have 2x. I got to multiply this times 3 also, so that's plus 3y. And then 5 times 3 is 15. So that is my standard form for number 3c. So slope-intercept form was up here, and I crossed out something. I shouldn't have done that. This was slope-intercept form, and this was standard form. Okay, so that is going to be on your classwork tomorrow. So we are done for today, and I didn't leave anything out in your notes, so we got everything filled in. Just come tomorrow prepared to do some work based on these notes, and I will see you tomorrow.